With DoubtNet, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download DoubtNet app today.
Hello everyone. So let's see this question. In this question it is given internal energy E also denoted by U. Every system having some quantity of matter is associated with a definite amount of energy called internal energy. The internal energy is the summation of the transitional, rotational, vibrational and bonding. Delta E, that is the change in internal energy, is internal energy of final minus internal energy of initial. And the change in internal energy is nothing but the heat supplied at constant volume, since all the heat supplied goes to the increased internal energy to the gas. It is an extensive property and state function. It is exclusively a function of temperature. And if the change in temperature is zero, then the change in internal energy is also zero. The internal energy of a substance is given by the following equation 3 PV plus 84, where U is given in kilojoule per kg and P is in kilopascal and V is in meter cube per kg. The system composed of 3 kg of this substance expands from an initial pressure of 400 kilopascal and a volume of 0.2 meter cube to a final pressure of 100 kilopascals in a process in which pressure and volume are related by PV square is equals to constant. If the expansion is quasi-static, then the value of Q is, right? So after reading the entire thing, what we should remember is, it is given that U is equals to, what is U? U is given 3 PV plus 84, right? U is given 3 PV plus 84, right? Now, after you have this U, what is that the initial state given to us? The initial state which is given to us is initial pressure which is given is the initial pressure which is given to us is 400 kilopascals, right? And the initial volume which is given is 0.2 meter cube, right? And the final pressure is given as 100 kilopascals, right? This is the final pressure. So you first of all require the final volume, right? We require the final volume first. So we have been given that this is the relation of the process, PV square is equals to constant. So from here you can easily say that P1 V1 square is equals to P2 V2 square. So from here you can write V2 is equals to V1 into P1 by P2 to the power half, right? You can write this. So from here what you will get, V2 is equals to, what is V1? V1 is 0.2 into P1 by P2 will be 1 by 4, right, to the power half. So from here you will get the value of V2 as 0.4 meter cube. So this is the value of V2. So we'll write here V final, that is V final is 0.4 meter cube, that is the expansion, right? Now you have find out the volume of V2. Now our aim is to calculate delta U. So delta U can be written as, what delta U can be written? 3 P1 V1 plus 84. So first of all it will be P2 V2, because delta U will be final minus initial, U final minus U initial. So you will be writing P2 V2, 3 P2 V2 plus 84 minus 3 P1 V1 minus 84. So from here finally what you can write, you can say that this will be 3 times of P2 V2 minus P1 V1, right? Or you can even say this, that if you take the 100 common outside from Pascal, so what you can say, it will be 1 into 0.4 minus 4 into 0.2, right? You have taken the 100 common from the pressure. So finally this will come out to be, delta U will come out to be minus 120 kilojoule, right? Because it was in kilopascal, so it will be in kilojoule. So minus 120 kilojoule, this is delta U of the system. Now we all know that PV square is equals to constant. It is a polytropic process. It is a polytropic process where N is equals to 2. So work done in polytropic process, work done in such processes is given by P2 V2 minus P1 V1 divided by N minus 1. So you can write down what is P2 V2. P2 V2 can be written as 100 into 0.4 minus P1 V1 is 400 into 0.2 whole divided by, what is N? N is 2. So because polytropic process is PV to the power n is equals to constant. So n is equals to 2 here. So finally you will write down 2 minus 1. Here you will write down it is 2 minus 1, right? So here you will write down 2 minus 1. So finally this will be equals to the value of work done. Value of work done will come out to be minus 40 kilojoule. If you have taken the Pascal in kilopascal, so it was 40 minus 40 kilojoule. So now what you have got the value of work done, you have got the value of delta U, that is the change in internal energy. So first law of thermodynamics we will use and calculate the value of Q. So first law of thermodynamics says that, what does first law of thermodynamics says? Delta U is equals to Q plus W, right? This is the first law. So from here what you are going to write, what is the delta U? Minus 120 kilojoule, that is equals to Q, you don't know, and work done is minus 40 kilojoule. So from here you will get the value of Q as, the value of Q will be equals to, the value of Q will come out to be minus 80 kilojoule, and this is only our required answer to the given question. So let's see what was given. If the expansion is quasi-static, then the value of Q is, so value of Q is 80 kilojoule. So which is our required answer? Option 1 is correct. So we'll write here that option 1 is correct, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download DeltaT app today.